Jai Hind. Today we are going to discuss pattern recognition from artificial intelligence, 5th unit. So what I am going to cover in this particular lecture, that is the background behind pattern recognition system, means where do we use it, where do we require it, and then we'll talk about pattern recognition system with an example after that, and then we'll talk about the design cycle that we use in pattern recognition system. So this is our pattern recognition system. In pattern recognition system, what we are having, we have the concept of machine perception. Where do we use it? What is the background? That is the machine perception. What we want in artificial intelligence, that whatever we are able to recognize with our human intelligence, that machine can do also. So that is what perception we want machine. For example, if we are speaking, then we want speech recognition. What is said by the machine? We need to recognize by the machine. The machine perceives the voice and then find out what has been said and what is done as a result of the said statement. If we are talking about character recognition, so again machine perception is there. Machine will read characters and it should be able to identify what is there, what is the character and how, where it is used, what are different characters in the input. Other things also, for example, images. In images, let me say we are having cats and dogs. Then we want to find out the pattern of cat and dog, and we want to classify the picture is containing a cat or is it containing a dog. So actually we want to recognize, the machine perceives something from the environment, and the machine has to recognize what it is consisting of, what it contains in the voice signal, in the voice, what it is containing in the image, what are the characters. So all these things we want to recognize through machine. So there we use pattern recognition system. So now what is a pattern recognition system which is able to recognize the image automatically? The machine is able to recognize the patterns in the images. For example, if I say there is an aerial picture of some land and let me see this is a flood hit land, then the machine should be able to find out the areas which are badly hit by the flood or partially hit by the flood. So we want to find out that patterns which are showing that this particular area is hit by the flood. So that is our aim, that is the background where we need pattern recognition. So now when we are clear with what are the patterns that we want to recognize, so now our topic is the recognition system. So what is pattern recognition system consist of? What it contains? The pattern recognition system takes input and give the decision. What is the input? That is the image or some voice, whatever we are taking. So that is our input and we want to take the decision. For example, the image is containing a dog or not. The image is containing a dog or a cat. So first thing is sensing. The part of pattern recognition system is it contains one sensing system. Sensing system means there will be sensors. Then after sensing, let me see the image. It is taking image of animals, cats and dogs. So it will sense, it will take the image, then it will segment the image. Now in segmentation, all the parts of the image will be segregated, will be separated from the existing other things. For example, let me say there is a picture of a dog. So dog will be segregated outline from the background. That is segmentation. Feature extraction. What are the features? Feature means what are the features of dog that it is recognized, that the dog can be recognized in the image. Then the classifier. We have used the feature. Based on that feature, we'll see what features we have extracted. So we'll tell it is a dog or a cat. Based on that, we'll do the classification. once we have done classification, we can improve our results with post-processing functions, and based on that, we'll take some decision. Okay, here we have shown one more thing, that we need some adjustments. What type of adjustment we may have, we'll see in further slide. For example, I'm having some data, I'm recognizing some pictures, and in some picture, let me say some information is missing. So what we are talking about, that we are having some features. Okay, we are having some features of the data, whatever examples we are taking. So it may be the case that the component of the data of one or two components are missing. For example, let me say we are doing the weather forecasting, and we are having few data which is containing temperature also, and at one instant of time, let me say today morning, my temperature measuring machine thermometer was not working well, so I couldn't measure the temperature today morning. So that one component that one data is missing from there. So we need to make some adjustment for these type of missing features. So now let us discuss one by one. So firstly, we are talking about sensing. When we have to sense, it means we need data, and whatever data we are taking, that may be image, that may be some voice. So we need a transducer. So the sensor could be a camera for images, or it can be a microphone for listening to the voice. Now, whatever pattern recognition system we are using, so sensors are very important for the pattern recognition system, because if we will take the reading with noise, it means we are having noisy data. For example, the images are very blurred. We are not able to listen to the voice very clear. For example, you have to recognize somebody's voice. So if voice is not clear, you won't be able to do a very good classification algorithm you apply, but you will not get a very good result. Accuracy will be low. Okay, so the PR system, the pattern recognition system, depends on the bandwidth, resolution, sensitivity, SNR, and distortion of transducers when we are talking about the performance of PR system. So if the picture will be very clear, enough clear, then we will be able to recognize the images. But if there is noise, then it will be difficult to do a proper classification. So sensing is very important. So that's why we try to, when we have very particular system, when we want to implement a very good performing system, we need a good camera, high resolution camera, so that we can pick each and everything. For example, if we have to read the nameplate while we are monitoring the traffic, then that should be clear. The image should be clear. If image will be clear, then we'll be able to recognize the characters correctly with a greater accuracy. Second part is segmentation. Whatever image we are taking, in that image there may be some overlapping images. For example, if I say a car is moving, two cars are moving in two parallel lanes, adjacent lanes. When you click a picture from one side, then it could be the case that two cars come in your picture overlapping. It means this in the same area in the picture you are having one car and the second is hidden partially behind that car. So that is the overlapping scenario. Okay, so we should do the segmentation such that all the patterns are well separated. We are able to recognize that there is behind different car. Both the cars should not be in one segment. Both should be segmented separately. Pattern should be well separated and should not overlap. Then only we can say that there is one car behind another car. If we will make that one segment, then we won't be able to recognize the two cars. The other part of pattern recognition is feature extraction. Feature extraction is very important part of pattern recognition. to characterize an object to be recognized by the measurement whose values are very similar for objects in the same category. Okay, so what we have to recognize, let me say we have to recognize cars. So for car, we need that there will be such type of body of the car, there will be wheels, front lights, back lights, all those things. Those are the features of the car. All car will have the same type of features. Okay, so we need to characterize what are those features. What are the features for which we can include, we can classify the car. Okay, for example, if I say weather forecasting, then the temperature is very important. So temperature is one feature. Today's temperature can be used to or subsequent temperature of subsequent days, continuous days can be used to forecast the weather for next. Okay, so it should be recognized well. The feature should be such that the object can be well recognized. Okay, and features should be discriminative. Discriminative means we need to take those features which is able to discriminate objects of two categories. For example, if I say cat and a dog, the cat is having few features, dog is having different features. Okay, so the feature that we select for identification of dog, that should be such that it is able to discriminate it from a cat. The feature should be such that that should not be same value, that should not have same value for a cat which it is having for dogs. The feature should be well discriminative. And invariant, the features that should we select, the feature extraction, it's very important because based on this only we are able to classify it. So the feature should be such that the invariant features means if we enlarge an object or we rotate an object, still that is the same object. For example, if we take a car, the picture of the car is taken from front or side or back, it is still a car. And if we talk about a dog, the dog is standing and we are taking a large picture, we are enlarging that picture or we are magnifying to a smaller value, we are reducing the picture, still it is a dog. So we have to take invariant features. After taking the picture, sensing, then doing the segmentation, and after deciding that what features we will take, the feature which are discriminative in nature and these are invariant to the different transformation like scaling and rotation, we need to go for classification. In classification, we use a feature vector provided by the feature extractor to assign the object to a category. So now we are having features. Based on those features, let me say we are having n features. So based on those n features, we are having the feature vector. This feature vector will be now used to find out it is a cat or it is a dog. It means to assign the object to a easy in comparison to when we talk about the feature extraction. But the problem comes when we are having the problems in feature, noise in feature values. Okay, so classification may get affected by the noise problem in the feature values may have some error while we were doing the measurement that affects the accuracy or performance of the classification. And last is the last component of pattern recognition system is post-processing. In post-processing, what we do, if we are having some information of the context, so that context input dependent information we can use to improve the performance. Okay, so a very popular example for this is if we have got this type of pattern. Okay, so it could be something like A or H. Both are the possibility for this character. So, but if we want the context means if we want that there was C before that, C character is recognized, and after that the character is T. Okay, so now if we know this context that it is placed between C and T, then we will take it as A, not H. So it will be recognized, this particular character will be recognized as A. So that is the exploit context input dependent information other than from the target pattern itself to improve the performance, because it depends that we might have done it or categorized it to H or A because it is having the similar type of shape. Handwritten characters, we can in handwritten characters we can have some variation of writing. Somebody may write some tilted H. Okay, but if we consider this H in this context, it is not H, it is A, and it forms the word cat. So that depends on the context dependent. That this type of information we can use in post processing, and we can improve the performance of our pattern recognition system. So let us try to understand with an example. So here we have taken the example from a book of pattern recognition. In this we are having a classifier. We are designing a classifier with two species, sea bass and salmon. So we are sorting incoming fish on a conveyor according to a species using optical sensing. It means we will sense the fishes. So these are on conveyor belt. These are the fishes. We can see from here that the fishes are overlapping in some part. So what is our aim? We will do the pre-processing to improve the performance of our images, the quality of images, so that we can have a good classifier. Then we will extract the features. Now we'll talk about this example. What could be the feature? For example, the length of the feature, the fins, where the mouth is placed, what is the size of fins or number of fins, what is the shape. Based on these, what is the texture, light, or whatever it is. So what is the width of the fish. So based on that we will extract the feature, and then we will do the classification, and in classification we'll come to know that it is salmon or sea bass. So let us try to understand this for feature extraction and classification. So first is we need to implement the optical sensing. So we need to set up a camera, and when we have set up a camera, we'll take the images. Now we are with images, and we have to classify from the images only. So we will take some sample images to extract the features. So here some suggested features are given. It could be length of the fish, lightness, width, number and shape of fins, and position of the mouths. So these are the different features that are used to recognize different types of fishes. So here we are talking about salmon or sea bass species. Okay. So firstly, what we will do the segmentation operation. In segmentation operation, what we will do, we will isolate fishes. Isolated fishes means we will have just one fish in the segment. If there are two overlapping fishes, for example, these two, then we will take one segment of this fish and one of this fish separately. Okay. And what else is there? There is background. So the fish has to be isolated from the background also. Use a segmentation operation to isolate fishes from one another and from the background. Okay. Now, firstly, we have set up the camera, took that. Now we have segmented the images, and now we are having a single fish segment. Information from a single fish is sent to feature extractor, whose purpose is to reduce the data by measuring certain feature. So the image of the information of the single fish is sent. Now we will measure the features. Okay. And these features that we will have, that we will decide, that will be passed to the classifier. Now, when we are talking about classifier, now what features are to be taken? Feature extraction should be such that the the fishes should be well classified, that it is salmon or sea bass. So let us understand the concept of feature with help of 2-3 features in our this particular example of classification of fish species. So if I select length as a possible feature and I try to draw length of salmon and sea bass, so here I can see that few salmon fishes are salmon are classified as sea bass if only I am measuring the length. So from here we are able to see that if length is in this particular segment, then these are maximum salmon, and if we see in this particular segment, maximum are sea bass. But again we can say that the salmon are classified here also. It means some salmon are having length greater than this and some are. Now this sum is not a small number, it's a big number. A big number of fishes have been, salmon fishes has been classified as sea bass, and same way sea bass has been classified as salmon. So it is not a good feature, it is a poor feature. Okay, then we tried another possible feature, that is lightness. Now if we see lightness in this, we are able to see that it is better than the length feature. Why it is better than? Here we can see that very few sea bass has been recognized. These sea bass has been recognized as salmon. Same way very few salmon has been classified as sea bass. So it is a better feature. Length was very poor feature in comparison to length. Lightness is a better feature for classification. Now we have taken a collection, means 2 features, lightness and width. When we are taking these two as the feature vector, now it's not a feature, now it's a feature vector. It is containing lightness as well as width. By taking lightness and width, we are able to see that if we classify, maximum objects are correctly classified. Very few errors are there. Very few objects has been, fishes have been wrongly classified. So it's a very good classifier in comparison to all. Now what the point is, we might add other features that are not correlated with the ones. We may have correlated features. It means one feature is dependent on another. So we should take the features which are not correlated, and we should avoid the noisy feature, because noisy features will reduce the performance of the classifier. And if we talk about the best decision boundary, that will be the one which will be able to find out the correct class of each instance. So if I see this, every object is correctly classified. But when we are drawing this boundary, do really we want this boundary? Because it is too specific to the data given. Because we are not designing the classifier for the given data. Given data we are using to classify, design the classifier. Okay, so what is our main aim? Our main aim is generalization. If your boundary will be so particular according to the given example, then it will not be able to correctly classify the novel input. And what is our central aim of designing the classifier? That is to correctly classify the novel input. Okay, so that is the issue of generalization. So if I consider this, it is not that much high dimensional as we have seen on the last slide. It was too much specific, so it was a high degree polynomial. Now we are having comparatively simple curve decision boundary, because we want the generalization, not the specific. Now design cycle. So that was our pattern recognition system. We need to take those features which are good to categorize, good to classify the underlying objects. So what is the design cycle? The first point is we collect the data, then we choose the features, After choosing the feature, as we have discussed in the pattern recognition system, we have some features that we extract. Now what we have to do, we have to do the classification. Now we are having number of algorithms for classification, so those model we have to choose. Once we have chosen the model, we will train that model, and finally we will evaluate that model for our particular domain in which we are doing the classification, whether it is cat or dog, image classification, or some other type of classification based on some numeric data. So when we do this data collection, so first part is we should have the data. Okay, whatever we do pattern recognition and we do some learning. Okay, so from data we learn the model, we decide a model and we train the model. And now the point is we need data to train that model. So first primary important thing is we have to collect the data. So how much data we have to collect? Okay, so this is very important to decide. How do we know when we have collected an adequately data and representative set of example for training and testing the system? It means we need data to train as well as test the system. So we should have adequate data, and data should be well represented. Well represented means it should be independently and identically distributed among the domain. For example, if we are designing a system for age prediction, then we should take the images and their age from each age category. We cannot design an age predictor by taking all the images of persons between, let me say, 30 to 40. No, it's not possible. We have to take images from different segments of age. Feature choice. Feature choice we have already discussed in detail. It depends on the characteristic of the problem domain. What will be feature? That depends on what problem we are taking. And we should take features which are well discriminative. Okay, which are having discriminative properties, plus simple to extract and irrelevant and invariant to the transformations. It should not be much changed because of or much influenced by the noise. Model choice. We are having number of models. Let me say one particular supervised models. Let me take one model from supervised learning. Let me say KNN. I took some data and I applied my classifier, KNN classifier, and I'm not satisfied with it. Then I'll go for some other, let me say Bayesian classifier, naive-based classifier, or SVM model, whatever it is. So it may be the case that we are not satisfied. Why it happens? Because no classifier is perfect in all the conditions. Different classifiers, classifying algorithms work in different domains. Okay. So if we are unsatisfied with the performance of our fish classifier and want to jump to another class of model, so that model choice is here, that which model we want to implement. Once we have decided we are using KNN or whatever Bayesian naive-based, so now it's time to train the model. We are having the training data. So we will use the data to determine the classifier. Many different procedures from training classifier and choosing the models are there. So that training will do here. And once we have fitted our model, we have trained our model. Now it's time to find out the performance. So that is the evaluation part. It measures the error rate or performance and switch from one set of features to another. If we are having few features, important features selected, for example, we selected length, we'll check the performance. If the performance is not good, then we can take the other features and so on. So that is our evaluation. So we'll start with data collection, then features will be selected, then model will be decided, then we will train the model, and then we will evaluate the model, and we can jump from one model to another based on our requirement, and we can use different features if we find low performance in case of selected features. So in this particular lecture, we talked about pattern recognition system, and we talked about the feature extraction, and then we talked about the design cycle that we use in pattern recognition system. Thank you. Jai Hind.